Today, let us discuss the problems based on the concepts we have discussed in earlier concepts. For example, coming to the first problem, here in this problem, alpha and beta are the roots of a quadratic equation given. This quadratic equation given is x square plus ax plus b equals to 0. Similarly, gamma delta are roots of another quadratic equation in y square plus cy plus d equals to 0. Then we have to find the equation of circle having alpha comma gamma and beta delta as extremes of a diameter. Diagrammatically, if you analyze, we require a circle. Suppose AB is a diameter of this circle if we assume. Given that one end of the diameter A is alpha comma gamma and the other one is beta and delta. Now we have to find out this circle in such a way that alpha, beta are roots of first equation and gamma, comma, delta are the roots of the second equation. Here, to find out this equation, we can have a simple calculation, that is just by adding the given two equations, directly we are getting the circle equation as x square plus y square plus ax plus b plus cy plus d equals to 0. Directly adding these two equations, that is x square plus y square plus ax plus cy plus b plus d taken as a constant equals to 0. Now let us see the concept and logic behind this to get the answer directly, how we are getting by adding given two equations. It is given that roots of the first equation are alpha and beta. So we can write this equation as x square plus ax plus b equals to x minus alpha into x minus beta equals to 0. In a very similar way, roots of the second equation are given as gamma comma delta. So this can be written as y square plus cy plus d equals to y minus gamma into y minus delta equals to 0. And we know already that if alpha, gamma, beta, delta are the roots of this equation, roots are the ends of diameter of a circle, in that case directly we can get the circle equation by using the standard result we have, that is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. So according to this case, simply the result will be obtained by adding these two equations, that is nothing but given two equations. So in such cases, directly we will get the circle equation by adding given two equations. Here, along with the solution of this problem, one should remember a small other concept also. In case if x square and y square coefficients are same, directly adding we are getting the circle equation required in this case. But when x square and y square coefficients are distinct, first before addition we should make x square y square coefficients equal, then adding the given two we are getting the circle equation required. Here not only this, the same question can also be tested in other way also. Here suppose these two are representing two pairs of lines, x square plus ax plus b equals to 0. On factorization you are getting two vertical lines. Similarly, y square plus cy plus d equals to 0. On factorization you are getting two horizontal lines. Here we can easily understand that these two pairs are forming a rectangle. Now we can draw circumcircle of this rectangle in this way, for which this AB becomes a diameter. That is why we can also say the same question other way as the circumcircle of the rectangle formed by these two pairs of lines can be obtained by using similar method. The same question can be tested in that way also. So here the finally most important point you have to remember in this cases is if x square y square coefficients are equal, simply adding we are getting the line equation. In case if x square and y square coefficients are different, first we make them equal and after that adding these two directly are getting circle equation. In this present problem here clearly the first option A is representing the required answer. Now let us see the next question. Now coming to the second question, the equation of circle which passes through the origin and cuts off length from the lines x equal to y and x equal to minus y is what? Here two lines are given in the question. This is the line x equals to y and one more line given x equals to minus y. Clearly according to the given question, we require a circle passing through the origin and also that makes intercept of 2 units on each of the given two lines. That means according to that if we roughly draw a circle, it will take in this form. Here the circle is passing through the origin and this is making intercepts of 2 units on each of the lines given. So now let us see how to find out this circle equation. Here because these two are making equal angles of 45 degrees in anti-clockwise and clockwise directions with x-axis, because it is angular bisector of these two cars, obviously center of this circle lies on x-axis. Here the center is lying on x-axis. Suppose take this center as some C. Now if we draw perpendicular bisector from center on one of these two cars, because this angle is 45 degrees, this is 90 degrees, this angle also 45 degrees. So this is clearly a right angled isosceles triangle and this chord is bisected by this perpendicular. That's why each part will be 1 and 1. So if this is 1, this is also 1. Applying Pythagoras theorem, this OC length will be root 2. Since OC length is root 2, this OC length will be abscissa of this point and obviously ordinate because it lies on x-axis is taken as 0. So here center of the circle is root 2 comma 0 and the radius is root 2 units. In a very similar way, one can imagine very comfortably that we can draw one more circle on the other side also, satisfying the same conditions, making 2 units intercept on each of these lines, and in this case the center will become minus root 2 comma 0. We can get it very comfortably in similar way. And if you observe closely the diagram given, why can't we draw one more circle satisfying the conditions and making so in the other quadrant? And similarly we can take one more circle on the other side. Like this, satisfying the given conditions, we can get exactly 4 circles which are passing through the origin and making equal intercepts, 2 units on each of this one. And coming to the last 2 cases, center lies on y-axis, that's why its centers will become 0 comma root 2, here 0 comma minus root 2. Then overall, if we take these circle equations, first 2 circle centers will be plus or minus root 2 comma 0 and radius is root 2. If we apply circle equation, x plus or minus root 2 whole square plus y square equals to root 2 square is 2. On simplification, x square plus y square plus or minus 2 root 2x equals to 0 on cancelling to both sides. In a very similar way, these two other circles also can be obtained as x square plus y square plus or minus 2 root 2y equals to 0. These are the required circle equations satisfying the given condition. So, according to the given options, the right answer is option A. Coming to third problem, according to the given question, there are two rods of lengths A and B which are sliding along the coordinate axis, which are rectangular in such a manner that their ends are always concyclic. Then the locus of center of the circle passing through these 4 points is dash. This type of questions to solve, as per the given conditions, first we are taking the coordinate axis, and given that two rods of lengths A and B are sliding on axis, here sliding cases we have to analyze very carefully, because a rod may be sliding on axis in this way whose ends are lying on x and y axis respectively, and another rod may be sliding like this. This is case 1. In this case, these are inclined with certain angle which is not rectangular, but as per the given condition, rods are to be sliding along axis rectangular way. That is possible only when the first rod is sliding along x-axis in this way and the second rod is sliding along y-axis in this way vertically. Only in this case these two rods are sliding rectangular according to the given condition. So, let us imagine these two rods taking positions AB and CD in a particular moment, whose lengths are given as A and B respectively. Now, one more condition included in the question, that these rods are always moving in such a way that A, B and CD 4 ends are always concyclic. If these 4 ends are concyclic, now let us imagine a circle is passing through these 4 points. Now let us imagine a circle chosen randomly as some s equals to 0. Let us take the circle equation passing through these 4 points as s equals to 0. Now we have to get such a variable circle center locus. We know that center of this variable circle is some minus g comma minus f if we are assuming, because already we have taken the point C here. Now let us take this point instead of C as some S. Now for this circle, AB is x-intercept and CD is y-intercept, whose lengths we know already as 2 root g square minus c, and y-intercept is 2 root f square minus c, which are equals to A and B respectively. On squaring both sides and simplifying, we are getting g square minus c equals to a square by 4, and that second equation will be reduced as f square minus c equal to b square by 4. Here the question requires here the locus of center of the circle, which to be taken as a condition in terms of G and F, and here the unknown term C is to be eliminated to get the condition required. So eliminating C, that can be obtained very comfortably by subtracting the given two equations. On subtracting the given two equations, we get g square minus f square equals to a square minus b square by 4. Now the locus of minus g minus f, if you want, just replacing minus g minus f with x and y, the required locus will be 4 into x square minus y square equals to a square minus b square. This is the required locus we are getting, which can be later stages proved as a rectangular hyperbola. So as per the given options, option C is the right answer to this question. This is the right answer to this. Coming to the fourth problem. Here we have to find out the equation of circle which passes through the origin and cuts off intercepts 2 and 4 on this coordinate axis. Here circle should satisfy two conditions here. One is circle is to be passing through origin and makes intercepts of 2 and 4 on coordinate axis respectively. According to the given conditions, if we draw a rough diagram to this, here circle should pass through the origin, and condition number 2 is it is making intercepts of lengths 2 and 4 on axis. So as per these conditions, if we draw a circle roughly. Now this circle, if you observe, it is passing through the origin and also this is making intercepts of 2 and 4 on coordinate axis respectively. Now to find out this circle equation, let us imagine its center somewhere as A. If the center is A, draw perpendicular bisectors from center to this chords. If we draw perpendiculars from center to this chord, obviously it will bisect both the chords. That is why here we are getting this part 2, this part 2, this part is 1, this part is 1. So if this length is 1 unit and this length is 2 units, by using Pythagoras theorem, we can show very comfortably that this length will be root 5. So here clearly OA, the radius of this one is root 5 units, and coming to the center coordinates, the abscissa of the center is nothing but equal to this value. This is nothing but 1, and ordinate can be taken easily as 2. So center of the circle here 1, 2 and radius is root 5 units. So easily we can find out the circle equation by using center and radius form. But according to the given question, we can also draw a circle satisfying the conditions in this way also. And in a very similar way, we can get circle equations satisfying these conditions in this way, in this quadrant, and also in this way. Like this, we can take 4 equal circles in 4 different quadrants having centers, and all these will take numerically the same center abscissa ordinate. Only the difference is according to the quadrant we are changing the sign. So here in second quadrant the circle center is taken as -1, 2, in third quadrant -1, -2, in fourth quadrant 1, -2, and radius of all of these circles is obviously root 5. Therefore the center for all these circles can be taken together as ±1, ±2, and the common radius to all these circles root 5. Applying center and radius form, the required circles are x ±1 whole square plus y ±2 whole square equals to root 5 square is 5. On simplifying these equations, we get x square plus y square ±2x ±4y. 1 plus 4, 5 cancelled both sides. So clearly we are getting 4 different circles by taking different combinations of these ± signs. According to the given options, the right option here is A. So the right answer to this question is option A. Coming to the fifth problem here, in this case we require the equations of circles which touch the x-axis at 3, 0 and makes an intercept of 8 units on y-axis. According to the given conditions, here the circle is touching x-axis at 3, 0. So let us locate the point A 3, 0 on x-axis, and the circle is making an intercept of length 8 units on y-axis. So as per the conditions given, if we draw the circle, we can draw one circle in this way, touching x-axis at 3, 0 and making y-intercept of length 8 units. And like the previous problems, here we can draw one more circle satisfying the same conditions. Here this circle also touching x-axis at the same point and making y-intercept 8 units. Now let us analyze the circle in first quadrant having the center. If you take the center of this circle as A, as we have discussed earlier, draw perpendicular bisector from this center to this y-intercept, and we know that it is perpendicular bisector, it will bisect 4 units lengths you are getting, and because this OA length is 3 units, this length also will be 3 units. Now if you observe closely in this diagram, this is 3, this is 4. If you join this, now this AP is clearly representing hypotenuse of this right angle triangle whose length is 5 units, 3 square plus 4 square under root. But this AP is representing the radius of this circle. That is why if you join this A with 3, 0, this point is, this length is also becoming radius, which is obviously 5 units, because already we have taken point A. Now let us take this center as A dash. Therefore, A dash, A length is again 5 units we are getting. So here radius of the circle is 5 units, and coming to the center coordinates, if we observe the diagram, this is 3 units which is representing clearly its abscissa, and ordinate is nothing but the distance from center to the x-axis. This value is clearly 5. So center of this circle is 3, 5 and the radius is 5 units. And one can say very comfortably that the second one, this circle center will be 3, minus 5 we can take, same coordinates. This center will be image of A dash with respect to x-axis. Therefore, both of these now containing the center as the required circles centers are 3, plus or minus 5 and radius common is 5 units. Therefore, circle equations required will be x minus 3 whole square plus y plus or minus 5 whole square equals to 25. We get x square plus y square minus 6x plus or minus 10y plus 9, 25 cancelled both sides equals to 0. So the required circles are x square plus y square minus 6x plus or minus 10y plus 9 equals to 0, which is clearly represented by option B in the question. That's why the right option to this question is option B. Coming to the sixth problem here. In this question, we have to find the equation of circle of radius A units given, and also the circle is passing through the points on x-axis at a distance of B units from the origin. According to the question given, here the circle radius is given, point number 1. Next, circle is passing through the points on x-axis at a distance of B units from the origin. From origin, if we choose a point at a distance of b units, clearly we have 2 points on x-axis which are at a distance of b units from origin. If you take this point as b comma 0, the other point is taken on the other side of this origin whose coordinates are minus b comma 0. So a and a dash are 2 points on x-axis which are at a distance of b units from origin. Now circle required is to be passing through these 2 points and radius also given as some a units. So as per the given conditions, if we draw a circle, this is clearly passing through these 2 points and radius is a units because these two lengths are equal and this is perpendicular. Obviously perpendicular bisector of any chord passes through the center. So center is clearly lying on y-axis. If we take the center as some c, now we have to get the coordinates of this c. To find out coordinates of c, here one more condition given is the radius of this circle. So from the diagram, this AC or A dash C is given as A units and this is B units. Now from Pythagoras theorem, this OC length will be A square minus B square. So we know this ordinate and we know this abscissa for this. That's why center coordinates will become now abscissa is clearly because the point is lying on y-axis, its abscissa will be taken as 0 and ordinate is root of a square minus b square. And easily we can analyze that. Satisfying the given conditions, we can draw one more circle satisfying all of these conditions whose center is on y-axis downward, negative y-axis. So its coordinates will be 0 comma minus root of a square minus b square will be taken. Now both of these together taken with centers 0 plus or minus root of a square minus b square and the radius equals to a units. We know the centers and we know the radius. Therefore, the required circle equations are x minus 0 whole square plus y plus or minus root of a square minus b square whole square equals to a square. If we simplify these equations or according to the options, even simplification is not completely required. Here x square plus, if we apply a plus or minus b whole square to this y square plus or minus 2 root a square minus b square into y plus a square minus b square equals to right side a square cancelled. Now x square plus y square plus or minus 2 root a square minus b square into y minus b square equals to 0 will be the required circle equations we can take here. So according to the given options, clearly option D is the right answer to this question. Now coming to the 7th problem, in this question 4y equals to x plus 7 is a diameter circumscribing the rectangle ABCD given with vertices A and B. Then we have to find out the area of the rectangle. According to the given data here, 4y equals to x plus 7 is a diameter given for the circumcircle of the rectangle. So let us start the diagram with circle here. if you are choosing a circle whose diameter is given as 4y equal to x plus 7, before that let us inscribe a rectangle ABCD as per the given vertices. Here vertex A is given as minus 3 comma 4. Randomly let us choose a point A minus 3 comma 4. Clearly point B is 5 comma 4. Here ordinate of B, ordinate of A both are 4 equal to 4. That's why clearly this AB is horizontal line whose coordinates of this B are 5 comma 4. Because it is a rectangle, obviously the other two sides are vertical. If you take this as C, this as T. Now A, B, C, D is the given rectangle with vertex A minus 3, 4, vertex B is 5 comma 4. Because we require the area of rectangle, in this we know already side AB, which is taken as length of ABCD, that is L equals to here AB length. Length of AB here is 5 minus of minus plus 3, 8 units. In this diagram, we are getting clearly length of the rectangle as 8 units. Now, to find out the breadth of this rectangle, one more condition is given. Here, 4y equals to x plus 7 is a diameter. Now, let us choose the diameter as this line. If you take the center as yes, this line is passing through the center. Now, this equation is 4y equals to x plus 7. This is a diameter. Now, because we know both of these coordinates AB, so we can get its perpendicular bisector also. If you are taking the midpoint of AB as n, n coordinates will be minus 3 plus 5, 2 by 2 is 1 and ordinate is 4. Here n is the midpoint of AB. If we draw perpendicular from n, because it is perpendicular bisector also, this also again becomes diameter of this circle. So now already one diameter is given, another diameter equation we can write down here. Because AB is horizontal line, its perpendicular line will be a vertical line whose equation is in the form of x equal to k, that is x equals to 1. So another diameter equation is x equals to 1. Solving this line and this line, we are getting the center coordinates. So substituting x equals to 1 in this equation, you are getting 4y equals to 1 plus 7, 8, then y will be 2. Clearly these coordinates are now 1 comma 2. This point is 1 comma 4, this point is 1 comma 2. So distance between these 2 points is clearly 2 units. And we can guess very comfortably this upper part is also 2 units. 2 plus 2, 4 units will be the length of AD. Therefore, the breadth of this rectangle B equals to 4 units you are getting. We know the length and we know the breadth. Therefore, area required equals to length into breadth, 32 square units will come. Therefore, according to the given options, option B is the right answer to this question. Coming to 8th problem here. In this problem, a square is inscribed in the given circle x square plus y square minus 2x plus 4y minus 93 equals to 0. Let us take this circle with the center is given as 1 comma minus 2, and radius of the circle is under root g square plus f square minus c. Minus of minus plus 93 will be 98 under root. Very clearly this is 7 root 2 units. 49 into 2 under root, written as 7 root 2 units. So we know the center and we know the radius of the given circle. In this circle, a square is inscribed such that sides are parallel to axis. So if we draw a square with sides parallel to axis A, B, C, D, if you are taking this as the square according to the given question, let us take the center as some S, because already we have taken this as C. Now let us assume this center as S. Now the question is, we have to find out vertices of this here. In the question only one of the vertices is tested. Let us see now how to find all the vertices at a stretch. Here, because these four sides are parallel to axis, now if we take this AC and BD, diagonals of these are diameters of this one. Clearly these are making, because these are making 45 degrees with the sides, equally inclined with sides. Now here this line is inclined, this line is inclined to the horizontal line with 45 degrees, and this line is, this diameter is making 135 degrees. So according to the given question, clearly we know the inclinations of both the diagonals of the square. Once if you know the inclinations, we can get the vertices very comfortably by using distance form of a straight line. Here if the center is x1 comma y1, and if you take the distance as r, here r also we can calculate, already it is taken as 7 root 2 units. All these four vertices are at a distance of r units from the center, and inclinations you know. Therefore applying distance form of a point on a straight line, you are getting A and C coordinates are x1 plus or minus r cos theta, y1 plus or minus r sin theta. Applying this result, here x1 y1 are 1 comma minus 2 plus or minus r is 7 root 2. Cos theta for these 2 points is cos 45, 1 by root 2. Here 7 root 2 into sin 45 also 1 by root 2. Root 2 cancel. We get two combinations taking both plus, both minus. 1 plus 7, 8, and minus 2 plus 7, 5. And similarly 1 minus 7, minus 6, minus 2 minus 7, minus 9. In very similar way, we can get the coordinates of this one. Here angle will become 135 degrees, and that is why we can also get these two coordinates by taking other two combinations in these signs, that is plus minus and minus plus. If you are taking other two combinations, here B and D can be written as 1 plus 7, 8, minus 2 minus 7, minus 9, and 1 minus 7, minus 6, and minus 2 plus 7, 5. So if we observe the options here, option B 8 comma 5 is observed directly here, and the remaining options here, no option is tallied with any other cases. That is why clearly 8 comma 5 as observed as one of the options, that is clearly option B. So the right answer to this question is option B. Just if you want only one vertex, we can use this, but here I am giving you overall idea how to get all the 4 vertices, especially when the square is inscribed in such a way that sides are parallel to axis. In this case, even if we want, we can write a standard general result also instead of doing every time this one. In such cases, if the center is minus g minus f, radius is r, and suppose the sides are parallel to axis, then here we can get vertices as minus g plus or minus r cos theta, minus f plus or minus r sin theta. Here theta, because if you replace with 45 degrees, they become minus g plus or minus r by root 2 minus f plus or minus r by root 2. By taking 4 different combinations, plus plus, plus minus, minus plus and minus minus, we are getting all the 4 vertices at a stretch. So we can avoid these lengthy calculations. Once if you are getting the concept comfortably behind this, we can use directly this shortcut approach also for getting this circle equation, and 4 vertices at a stretch directly from this circle. Now let us discuss a different model comparing to previous cases. Question number 9. Here a circle is given and a point is given. From the given point, we have to find out the shortest distance to the given circle. Let us take the circle here as some s equal to 0, whose center is given as 3 comma 2. Center of the circle is 3 comma 2. Radius of the circle is 9 plus 4 13, minus of minus plus 12 25, under root is 5 units. Center we know, radius we know, and the given point is minus 2 comma 14, because minus 2 comma 14 distance from the center is clearly more than radius, because the point distance from the center is more than radius, hence the point is external to the circle. If you take this point as P, from this point if you join various points, if you join these 2 points, these 2 points, like this, if we connect various points, various distances to the circle will come. Among all these, if we have to choose the shortest distance, one can say very comfortably that if we are drawing diameter passing through this given point, if this diameter cuts the circle at A and B respectively, then PA will become shortest distance and PB will become the longest distance to the circle from the given point. So now we have to find out the shortest distance PA in this question. Here from the diagram we can get very comfortably the distance PA here, because the shortest distance PA equals to, from the diagram we can write it as CP minus this AC. AC is nothing but radius. So the shortest distance from an external point to the given circle will be CP minus R. In a very similar way, the longest distance PB equals to Similarly, the longest distance PB equals to CP plus R. We can directly use these results here. And one more thing, in case if the point given is internal, in this case we have taken the point external. Suppose in case if the point given is internal, if we draw the diameter passing through this point, somewhere here center we have, here A we have, here B, then shortest distance PA will be equals to radius total minus this CP. The difference between that and this case is, here CP is more than R, that's why we have taken CP minus R, and in this case we are taking R minus CP. So instead of checking the position of the point directly, if you want to calculate the shortest distance, simply we can use modulus, whether it is R minus CP or CP minus R. Finally we take the positive output. In that case we can avoid unnecessary lengthy steps calculations. So here coming to this case, the shortest distance is CP minus R. In this problem, CP equals to under root minus 2 minus 3 minus 5 square 25 plus 14 minus 12, 14 minus 2, 12 square is 144. Under root will be 13 units and R is given as 5 units. Therefore, the required distance is, shortest distance is 13 minus 5 equals to 8 units will come. So according to the given options, clearly option A is the right answer. In a very similar way, the 10th question also we can answer. There, instead of asking the shortest distance, you are asked to find the longest distance. So in this 10th problem also, you are asked to find the longest distance from the given point to the given circle, which can be calculated comfortably as option D, 6 units. That's why we can take the next question right answer as option D. Now let us see another model, question number 12. In this problem, mi and 1 by mi, where I takes from 1, 2, 3, 4, that is m1 1 by m1, m2 1 by m2, m3 1 by m3 and m4 1 by m4 are given as concyclic points. So if we imagine a circle here, the given 4 points A, B, C, D randomly chosen somewhere, m1 1 by m1, m2 1 by m2, m3 1 by m3 and m4 1 by m4. All the 4 points are lying on this. In this case, we have to find out the product of m1, m2, m3, m4. It is to be proved as independent of the circle taken, because the options also given without the circle involved here. That is why we may get the result which is independent of the circle chosen. Wherever you choose the points, whatever the circle passing through these 4 points, obviously product of these 4 should be a constant should come. Let us see how to get this case. If we choose the circle equation as a randomly chosen one, standard form s equal to 0, and instead of taking these 4 different points, because each point is in the form of m comma 1 by m, substituting this point in the circle equation, the circle equation is x square plus y square plus 2gx plus 2fy plus c equals to 0. In this, substituting m comma 1 by m in this equation, we get m square plus 1 by m square plus 2gm plus 2f by m plus c equals to 0. On simplifying this equation, we get m power 4 plus 2gm cube plus c into m square plus 2fm plus 1 equals to 0. Clearly, it is a biquadratic equation in m, which is supposed to contain 4 roots, which are already given as m1, m2, m3, m4. So, roots of this equation are m1, m2, m3, m4. Now, as per the question given, we require the product of these 4 roots, and we know that product of roots of a biquadratic equation is a4 by a0. So, if it is a0, a1, a2, a3, a4, a4 value is 1, a0 also 1. Whatever circle randomly we are choosing, this m cube coefficient, m square coefficient, m coefficient are involved with this variable term g, c and f, but product of these 4 roots is depending on these 2 extreme cases, that is, which is always representing a constant. That's why m1, m2, m3, m4 value is always 1 will come, independent of the circle chosen and position of the points chosen. So, according to the given options, the right answer is option A. Let us see question number 13. In this problem, a variable circle is passing through the fixed point P comma Q given. So, let us choose a variable circle passing through the point A P comma Q. Randomly we choose a point P comma Q on the circle, and the circle given is touching x-axis. This circle is touching x-axis. These are the conditions given. Circle is passing through the point P comma Q and it is touching x-axis. Now we have to get the locus of other end of the diameter through A. If we draw diameter passing through A, if you are taking the other end which is variable as x comma y or x1 comma y1. If the other end of this diameter is taken as x1 comma y1, now we have to get the locus of this other end x1 y1 in such a way that circle formed by taking this as diameter is touching x-axis. Here, because we know both the ends of the diameter of this circle, circle equation can be, the circle equation can be written as x minus x1 into x minus p plus y minus y1 into y minus q equals to 0. Here, this is the circle equation. Now we have to take the condition that this circle is touching x-axis. If a circle is touching x-axis, then we know that already we have a condition g square equals to c. So, first we write the circle in standard circle equation form, and applying this condition automatically the locus will come. Let us simplify the circle equation. X into x, x square, plus here y into y, y square, minus of x1 plus p into x plus minus of y1 y minus of q. So, here minus we can take common in this also, minus of y1 plus q into y plus constant terms here px1 plus qy1 equals to 0. Clearly the circle is in its standard form, x square plus y square plus 2gx plus 2fy plus c equals to 0. Now if this circle is touching x-axis, the condition is g square equals to c. Applying this condition, g is plus half of this x1 plus p whole square by 4 minus of minus plus x1 plus p by 2 square is this one equals to constant px1 plus qy1. So x1 plus p whole square equals to 4 times px1 plus qy1 is coming. This is the condition we are getting. Now if we simplify this equation further according to the given options here, we know that a plus b whole square minus, transferring this left side, x1 plus p whole square minus 4px1 equals to 4qy1. A plus b whole square minus 4ab is a minus b whole square. So we can write it as x1 minus p whole square equals to 4qy1. Then its locus is x minus p whole square equals to 4qy will come. Clearly the required locus in this problem is x minus p whole square equal to 4qy. Clearly option A is the right answer to this question.